Hey everybody, TK here. I'm back in China and I'm in my own kitchen, which is really nicely equipped. And I'm doing some home science today because, yes, I'm an English teacher, but we don't teach English directly. We teach it through course subjects. And so the subject that I teach English in is science. And I have a lab that I'm going to be doing with my students. And I've got to get it ready. And I'm going to take this red cabbage, which I just bought at the store, and I'm going to blend it up with my little hand blender. Here's the base. And then I'm going to boil it and make cabbage juice. And that cabbage juice is supposed to be change colors when I put different chemicals in it to indicate acid versus base. So I've never done this before, and I'm teaching it tomorrow in class, so I've got to get it ready, and hopefully it works. So we'll see what happens, and come along for the run. Okay, I'm going to cut in here. It's a little noisy now because I've got the fan on the hood over the stove. But what I'm doing right now is I'm rendering the cabbage. You can see I've got a nice boil going on. And for language learners, rendering means that I'm cooking it down and taking the things that I want out of the solid, and I'm making it liquid. You can render fat, for example. You take a bunch of fat and you render it and you get the grease out, and then you can cook with that. That's lard. I'm not making lard because this is vegetable, but I'm making a juice. And you can see it's nice and dark. And that's what we're looking for, is a nice dark cabbage juice. Now, tricky thing you're going to see, I'm going to put it back on quick speed here. I realized once I got started that I don't really have a good sieve to get just the juice and not the solids. I have a colander, but the holes are too big. So what I'm going to do is I'm going to carefully pour the rendered juice through my teapot here, and it's small enough to catch tea leaves. That'll catch the blended up cabbage bits. And so then I can pour this into another container to use for science class. You may have noticed I was using distilled water. I normally drink the distilled water and use the house tap for everything else, but I don't know what the pollutants are in local water, and they might be slightly acidic, they might be slightly base. And since this is for a base and acid test, I really wanted pure water as close to an even 7 as I could get. So I'm using the distilled water that I used to drink to make my juice. Alright, we'll go back into fast speed. Okay, so I've rendered it down and poured it into the teapot, and let me stop and make a quick safety note here. You saw me reaching into the teapot with my bare fingers. Even though it was still steaming, I had actually let it cool for quite some time before I decided to turn on the camera and do the pour, because I knew I would scald myself if I had to do that, and I was expecting to have to do that. So make sure that you cool it down enough to handle before you start sieving your material, unless you have a really big sieve and some spoons, because I ended up with a lot of solids. Here's about half, actually about a third of what I have left. You can see it's cooked down. Instead of being stripy with white and purple blotches, and it's all about the same color. So it's all rendered, and I've got a teapot full of liquid, and you can see I spilled some, so it's a nice dark purple. I didn't want to clean it up till I showed it. But here's the whole point of the experiment. Why am I doing this? And the answer is, this is an acid-base test. I have here a glass with dissolved baking soda and a glass with vinegar. Okay, and if this works right, if it does what it's advertised to do, then we're going to see, using this lovely dark purple liquid, what we're dealing with, whether we're dealing with acid or base. And so I'm just going to pour a little bit of my dark purple liquid into the vinegar, and there you go. And into the baking soda, just a little bit, because I have to save it for tomorrow. Into the baking soda. And there you go. So, what's our takeaway from this? Vinegar, which is an acid, turns red. Baking soda, which is a base, turns blue. And the closer you get to 7, the closer you get to neutral, you end up with towards the middle. So we have on the high acid end, red, orange, yellow, green, blue, indigo, violet. And just for kicks and giggles, I have here, people have always wondered what's the difference between baking soda and baking soda and baking powder. Now, I dissolved some baking powder into this glass, and it immediately began to fizz, so it may not do what we want to actually reveal. But baking powder is baking soda with some dry acid mixed into the powder. Aha. That allows it to react immediately once it's wet. And you can see it's a much lighter blue. It's far less basic. And so the acid that has been mixed in has changed the value of acidity. And when that gets wet while you're baking, you get a reaction. And that's why some recipes call for baking powder and some call for baking soda. If it's a baking soda recipe, look in there and I can guarantee you're going to find something else in that recipe that is an acid, because otherwise the baking soda won't do what it's supposed to do. With baking powder, you have that dry acid mixed in, and it enables usually a doughy product to rise with the fizz from the baking powder. All right, so that's the experiment, and we're going to get some different liquids and show off how to do this tomorrow in my science class so that my students can use our basic elements. Remember, we're using a red cabbage. I'm saving this to show them because I don't know if my students know the English words for this vegetable. And you can render it down and test for acidity or basic properties in a liquid. See you later.